Hello friends, I welcome you to my YouTube channel MacPM. So in this video we will solve a problem which is based on hydraulic forces on the submerged surfaces. So let's read the problem. A vertical sluice gate is used to cover an opening in a dam. So this is a dam, okay, and this is a gate. So this is the opening. From here water can go from to other side, but this is closed using a sluice gate. Okay, the opening is 2 meter wide. The width is not shown here, but suppose this is plate like this, then 2 meter is its width, and 1.2 meter high, 1.2 meter height, which is already shown here, 1.2 meter. Okay, on the upstream of the gate, the liquid has specific gravity of 1.45. So this liquid has a specific gravity of, see, B is equal to 2 meter. We will note down the parameters, so it will be easy. H is equal to 1.2 meter. Specific gravity on left side is 1.45. Large up to height of 1.5 meter above the top of the gate. So above the top of gate, height is 1. Height above the top is 1.5 meter above the top of the gate. Where is the downstream side? Water is available. So downstream side, so rho L is 1000 kg per meter cube, or right side density 1000 kg per meter cube, because it is water up to height touching the top of the gate. So it is up to the height of the gate. Find the resultant force acting on the gate and position of center of pressure. So we have to find F resultant and center of pressure resultant. Okay, find also force acting horizontally on the top of the gate. So if this force, suppose this is a gate and resultant force is acting here, and this is hinge here around this point, it is hinge, then we have to find the force here which is acting, because this force is trying to open the gate. So this force which will be required to close the dam, acting horizontally top of the gate, which is capable of opening it. Assume that the gate is hinged at the bottom. So this gate is hinged here, this force is trying to close it, then we need this force which will be capable of opening it. Okay, so first of all, on left side we have specific gravity 1.45. so density of liquid on left side will be equal to specific gravity into density of water. So it will be equal to, this is the formula, because specific gravity is the ratio of density of liquid divided by density of water. So we will just multiply with density of water. So density will be 1.45 into 1000 kg per meter cube, it is density of water. So 1450 kg per meter cube is the density of liquid on the left side. Okay, so first of all we will try to find the what are the forces which are acting on the left side and right side due to the water columns. So F is equal to rho A G H bar. Okay, so rho is density, already know. A is the area of the gate, so A is equal to B into H, because it is rectangular. So 2 into 1.2 is equal to 2.4 meter square is the area. Now G is known to everyone, 9.81. H bar is the, on left side, is the height of liquid from the center of gravity, from distance of center of gravity from free surface. So you can see here, this is 1.5 meter plus center of gravity will be half of this height, so this is 1.2. So 1.5 plus 1.2 divided by 2, so it will be equal to 1.5 plus 0.6, it will be equal to 2.1 meter on left side. Okay, so force on left side will be equal to rho is 1450 into A is 2.4 into G is 9.81 into H bar is 2.1. Okay, so if you will multiply these all, then you will get 71691 Newton. This will be the force acting on left side at a distance of, so we will find the distance at which it is acting. So H star on left side is equal to Ig upon A H bar plus H bar. Ig is moment of inertia of the surface along its center of gravity. So for rectangle it is bhq by 12. So b is 2 into h is 1.2 q divided by 12. So it will be equal to 0.288 meter to the power 4. So H star on left side will be equal to 0.288 divided by area we had calculated 2.4 into H bar we had calculated 2.1 plus 2.1. Okay, so if you will calculate this, then you will get 2.1571. So this is the value. So let's note it down. Force on left side is equal to 71691 and H star on left side is 2.1571 meter. Similarly on right side, let's calculate on the right side. So force on the right side is equal to rho A G H bar on the right side. So these are, so rho density is 1000 because it is water, 1000 kg per meter cube. Area will be same for the gate, so it is 2.4 into G is 9.81 into HR. H bar on right side is distance of center of gravity from free surface. So free surface is up to gate here, so it will be half of this height, which is equal to 1.2 by 2, which is 0.6. So from here we can find the force on the right side. So please calculate from the calculator. Sorry, there is a little bit delay because my calculator is not working. So it will be 14126 Newton. So this is the value of force here. Okay, so similarly H position of center of pressure at right side will be equal to Ig divided by A H bar in right side plus H bar on right side. So it will be equal to, we had already calculated Ig, which is 0.288 divided by area is 2.4 into H bar is 0.6 plus 0.6. So if you will calculate this, you will get 0.2 plus 0.6 is equal to 0.8 meter. Okay, so this is distance from free surface. So if you will try to find its distance from hinge, so you can see in the diagram this distance is from here. So if we are trying to find this distance, then it will be equal to 1.2 minus the same. So distance from hinge, h star rise from hinge will be equal to 1.2 minus 0.8, which will equal to 0.4 meter. Okay, similarly also in left hand side, if we are trying to find distance from hinge, f left star from hinge, then it will be equal to, see, this total distance 1.5 plus 1.2 minus this h star, 1.5 plus 1.2 minus 2.1571. So if you will calculate this, then you will get 0.5429 meter. Now if you will try to find the resultant force will be F1 minus F2, which will be equal to 71691 minus, which is, we have written FL minus FR, which is equal to 14126. If you will subtract this, then you will get 57565 Newton. Okay, this is the resultant force. Now what will be the resultant location at which this force will be acting, means resultant center of pressure. So H star actual, which is resultant, will be acting on, see, it will be equal to F1 H1 minus F2 H2 divided by F1 minus F2, because F1 and F2 are in opposite direction, so it will be like this. So F1 is 71691 into H1 is 0.5429. we are taking distances from the hinge, okay, minus force in second side is right hand side, say here 14126 into H2 is distance from hinge 0.4 divided by 71691 minus 14126. So if you will calculate this, then you will get 0.578 meter. Okay, this is distance from hinge. So actual center of pressure, which is resultant, which will be above 0.578 meter above hinge. Now we had to find, see, this was gate, this was hinge here, okay, and we had to find force F which could open it, and this height was 1.2 meter. Now we know that the resultant force was 57565, and this distance at which it is acting is 0.578. okay, so to find F, we can do moment about this point C or H. Hinge point should be 0. Okay, moment about point H is equal to 0. So we can do 5, 7, 5, 6, 5 into 0.578 minus F into 1.2 is equal to 0. So F is equal to 57565 into 0.578 divided by 1.2. So if you will do this, then you will get, let me calculate, 57565 into 0.578 divided by 1.2. If you will calculate this, then you will get the resultant for 27727.14 Newton. So you will need this much force to open this sluice gate. Okay, because from this side this much force is already acting, and this at this point which is creating a moment to close it. So we need opposite and equal movement, which will be equal to this force into 1.2 meter. So I hope you understood this problem. If you have any doubt, then please ask in the comment section, and if you like this video, please subscribe and share to our channel. Thank you for watching.